Session 8.5 Solving Linear Inequalities to Make Predictions. Addition properties of inequalities. If A less than B, then A plus C less than B plus C. This is the same idea for the equation. If we let the C on the left-hand side, you're going to do the same thing on the right-hand side. And for the inequality, it doesn't change from here. Similar properties hold for less than or equal to, greater than, and greater than or equal to. Multiplication properties of inequalities. For a positive number C, if A less than B, then A times C less than B times C. This is talking about if your C is a positive number. When you multiply the C for both sides, the inequality here doesn't change. Look at this example. 2 is strictly less than 3 here. And now, if I multiply 4 for both sides, multiply 4 on the left-hand side, multiply by 4 on the right-hand side. When you multiply it, 4 times 2, that will be equal to 8. 8 less than 3 times 4, which is going to be the 12. After you multiply a positive number, we still get the true statement in here. However, for a negative number C, if A less than B, then A times C is going to be greater than B times C. Okay, we're going to switch the sign from here. Look at this example. 2 less than 3. If we multiply the negative number for both sides, so think about it, negative 4 times 2, we're going to get negative 8. And this is going to be negative 12. If I still keep the strictly less than sign from here, negative 8 strictly less than negative 12, then we will get the false statement. So, according to the multiplication properties, if we multiply the negative number, we need to switch the sign. This is as less than, we're gonna switch it, make it like greater than. Similar properties hold for less than or equal to, greater than, or greater than in equal to. And I want you guys to highlight the last sentence here. When we multiply both sides by a negative number, just like our example, we reverse the inequality symbol. We're going to switch the sign from here. Linear inequality in one variable. A linear inequality in one variable is an inequality that can be put into one of the forms. We have the mx plus b. Okay, remember mx plus b? This is the linear equation with one variable. And x here, that will be our variable. M and the b, this is considered a constant. So mx plus b strictly less than 0. This is called linear inequality in one variable, or mx plus b less than or equal to 0. This is also the linear inequality in one variable. Solution set and solve. We say numbers satisfy an inequality in one variable if the inequality becomes a true statement after we have substituted the number for the variable. This is the same idea when we're working on the equation. What is the solution? Solution means if you plug in the number that is satisfy the inequalities, and we're gonna get the true statement. So we call this is gonna be the solution. For example, solve 2x minus 3 strictly less than 7. So this is the inequality with one variable. Descriptive solution set has an inequality. So we want to find out what is your x in here. And your solution set should be inequality. You should have something like x less than something or x greater than something. And find out the interval notation and on a graph. We need to find 3 things on these questions. First, find out the solution set. Second, find out the interval notation. Third, you're going to graph it on a graph. So 2x minus 3 strictly less than 7. Just consider this is like an equation. So we want to isolate the 2x in here. So how can we get out the 3? We do have a negative 3, so we're gonna pass 3 for both sides. So here I could cancel out. I left with the 2x. 2x less than 7 plus 3, which is gonna be the 10. Okay, I want to isolate my x, so I'm gonna divide it by 2 for both sides. Cancel out, x is gonna be less than 5. So x strictly less than 5, this is gonna be our solution set has an inequality. Now we want to graph it on the number 9 in here. So we do have the number 9, 0, 1, 2, 3, 4, 5. You could see we're gonna use the open to represent it. Open here means this is a strictly less than or strictly greater than. Okay, one more time. When you use the open, means this is a strictly less than or strictly greater than. And you could see we're gonna point to the left. That means all the numbers on this line will be the solution of this inequality. For example, x equal to 4. X equal to 4, when I plug it in, 4 strictly less than 5. This is good, right? 3, plug in here. X equal to 3, so 3 strictly less than 5 here. Okay, so that's why we're gonna point to the left. So we call this is graph your solution on the number 9. Then last one, interval notation. Okay, we need to write your answer in the interval notation. So my interval notation is gonna be the parenthesis. Parenthesis means not equal to. Starting from negative infinity and keep going until to the 5 in here. I'm gonna use the parenthesis here because this is strictly less than. Okay, this one, the interval notation, we always look at it from the left to the right. Okay, on the left hand side, this is gonna be starting from negative infinity until we're gonna stop at 5 here. So that's why I'm gonna put the 5 in here. Okay, next example. I want you guys try to do it by yourself. Solve for your x. Okay, check your work. First step, we're gonna subtract the 6x for both sides. Okay, we want to combine the 9 terms. So we want to get off the 6x from here. We're gonna subtract the 6x for both sides. 2x minus 6x, that will be negative 4x. Okay, negative 4x minus 5, strictly greater than. These two, you're gonna cancel out. You're left with the 3 here. Okay, now I want to isolate my negative 4x. We want to get out of negative 5 in here. So what we're gonna do, we're gonna add 5 for both sides. Cancel out here. I have negative 4x strictly greater than 3 plus 5, which is gonna be equal to 8. And then we want to get out of the negative 4 here. So we're gonna divide it by negative 4 for both sides. Remember when we multiply or divide it with the negative number, we need to switch my sign in here. So that will become divided by the negative 4. I'm gonna switch the sign. That will become strictly less than. These two cancel out. So that will be x less than negative 2. Highlight this part on your notes. When you multiply or divide it with the negative constant, you need to switch your sign here. So this is going to be your solution set has an inequality. Now we want to graph it on the number 9. So when you have the x on your left hand side, and you're going to see this as a strictly less than, you could think about it, this is just like the arrow, point to the left. So I will have the negative 2, I will have the open here because this is a strictly less than, and then point to the left again. Double check your work. Let's say I'm gonna plug in negative 5. Negative 5, that is a strictly less than negative 2, right? This is a true statement. And then we're gonna write it in the interval notation from the left to the right. So on your left hand side here, this is gonna be negative infinity, comma, -2. Okay, so this is the interval notation. Starting from the left hand side, negative infinity to -2. And parenthesis, because this is a strictly less than. Okay, one more. So this one, we have the parenthesis here. We want to distribute the 3 for both of them. So we have the parenthesis here. We want to distribute the 3 here. So you should get 3x minus 3 times 2, which is going to be the 6. Now we're going to subtract the 5x for both sides. So 3x minus 5x, that'll be -2x. -2x minus 6, strictly less than 3. Now we're going to add 6 for both sides here. So cancel out. I only have a -2x less than +3. Okay, now we're gonna divide it by -2 for both sides. Again, when you divide it in negative constant, you want to switch the sign here. So you should get x greater than -3/2. Okay, graph your solution. So this time, this arrow button point to the right, right? So we will have about -1.5, which is going to be -3/2, point to the right. Double check. When you plug in x equal to 0 here, 0 is a greater than a negative number. Or 1, +1, should be greater than a negative number. Okay, now we're gonna write it in interval notation. So we always look at your solution from the left to the right. So that'll be parenthesis -3/2 to +infinity. Okay, another example. Substituting values for variables in a compound inequality. So I have the compound inequalities. Look at this guy. I do have 2 inequalities in here. And actually, if you look at it, you could consider this is going to be the 2 equation. First equation, that will be the x bar minus t times s divided by the square root of n, strictly less than the mean. This is the first equation. Second equation, that will be this one. The mean less than the x bar plus the t times s over square root of n. But since this is compound inequality, we could combine these 2 equations together and work on it at the same time. So right now, I want you guys plug it in. The x bar here, this is talking about the sample mean. Plug in the sample mean 20.3 in here. T equal to 1.708. That'll be this guy. The S equal to 7.6. That'll be here. And N equal to 28. That'll be square root of the 28 in here. Okay, plug in this number to this compound inequality. Okay, you should have this guy. You should see this is going to be 1 negative and 1 positive. And now use your calculator. Okay, just use your calculator, plug in everything from here. You should get the answer from here. And this means the variable of the mean would be between 17.8 to 22.8. Okay, now we're gonna graph it. This is a 17.8 somewhere like here. Again, we use the open because this is a strictly less than. And then keep going, 22.8. We stop about like here. So means like your solution, means like your mean the solution of the mean will be in between these numbers. Now we're gonna write it in the interval notation. So from the left to the right, we're starting from this point, parenthesis 17.8 until 22.8 close parenthesis. Okay, solving the compound inequality. So again, we do have a two equation here. This is the first one, and this is gonna be the second one. But we could do it at the same time. So we just keep in mind we're gonna keep the variable x in the middle. And we try to isolate the variable of the x in here. Okay, and then whatever you wanna do in the middle, you're gonna do the same thing on the left hand side, and then you're gonna do the same thing on your right hand side. So first step, we want to isolate the 2x. We're gonna add one from here. So once you add one here, you're gonna add one here and gonna add one here. Okay, we're gonna take care of the compound inequality at the same time here. So add one here, and add one here. So this has become -4 less than 2x less than 8. Now I want to isolate my x. So I'm gonna divide it by 2. So if I divide it by 2 here, I need to divide it by 2 here, and I want to divide it by 2 here. So you will have x in between -2 to 4. Okay, graph the solution. So your x will be in between from -2 to 4 here. Okay, write it in the interval notation. So that will be parenthesis -2 to +4 close parenthesis. Making a prediction. Digital music revenues in the United States are shown in the table for various years. Let R be the annual revenue in billions of dollars at T years since 2000. Okay, so remember this guy? Means T equal to 0 when the year 2000. So figure out what is your T when the year 2006, what is your T when the year 2008. Okay, a reasonable model is R equal to 0.34t minus 0.11. So we have the linear equations in here. Estimate when the annual revenue was more than 3.7 billions. So we have the reasonable models in here. Now we want to estimate the annual revenue. Okay, annual revenue is talking about the R when your R was more than 3.7 billions. So means I'm gonna let this model 0.34t minus 0.11 greater than 3.7 billions. We have this inequality. Now we want to solve your t in here. So how can we get out of this guy? We're gonna add 0.11 for both sides. Simplify it. You will get 0.34t greater than 3.81. Now, we want to divide it by 0.34 for both sides. So here you could just use your calculator. You should get t greater than 11.21. So now we need to figure out when t equal to 11.21, which year is gonna be. So t equal to 0, this is gonna be year 2000. Right now you have the t equal to 11. So you're gonna add 11 from here. That will be 2011, right? So according to the model, the annual revenue was more than 3.7 million after 2011. Okay, after 2011. That's it.